Assalamu alaikum wa rahmatullahi wa barakatuhu. My dear children, the last essay question I gave you is from 2016 new syllabus paper. It is the third question, right? As shown in the following figures, magnesium chloride, sugar, and grease are added to the test tubes A, B, C, D, E. After that, the substances in the tubes are stirred well, right? In that one, your first question, A part, in which test tube a solid, liquid, heterogeneous mixture will be created? You need a heterogeneous mixture. The basic property it is an ionic compound, okay, will form, or otherwise you can say a polar material will form a homogeneous mixture with a polar material. A non-polar material or a non-polar substance will form a homogeneous mixture with a non-polar. So if you want a heterogeneous, these two will form a homogeneous mixture. If one is polar and other one is non-polar, then it will form heterogeneous mixture, right? Now, if you take magnesium chloride, it's an ionic compound. Ionic compounds you need to take as polar. Sugar is also a polar substance. Okay, grease is a non-polar substance. Distilled water is a polar substance. And kerosene is non-polar, right? So if you take these answers, the first answer, magnesium chloride and distilled water, polar, so homogeneous. This is magnesium chloride, distilled water, polar, homogeneous. Sugar, polar, distilled water is also polar. Again, polar, homogeneous. Sugar is polar. Kerosene is non-polar. That is a heterogeneous mixture. Grease is non-polar. Kerosene is also non-polar. That is once again a homogeneous mixture. Non-polar will form homogeneous mixture. So in which test tube a solid, liquid, heterogeneous mixture mean? You need to say D. Test tube D is going to be your answer. Okay, these are explanations for you. Okay, your answer is D. Question number B, when you take write respectively the solute and the solvent in this mixture. In the mixture you appointed D, the solute is sugar and the solvent is the kerosene. The solute is sugar and the solvent is kerosene. Actually, for this kind of a question, it's not right to say which one is solute, which one is solvent. Solute, solvent, the words are applicable only for homogeneous mixtures. But when your examiner asks in that pattern, you don't have a choice. Then you need to write and come. Okay. Question number 2, it is solubility of a solute. You are expected to write the definition. In the classes I used to emphasize, you write a compilation of the definitions. You collect all the definitions in one book. Okay, then that will be a worthier work for you. Okay, here you have to write solubility is the maximum mass of a solute. Maximum, the word is very important. Maximum mass of a solute that can dissolve in 100 gram. That is the second condition. 100 gram of a solvent at a certain or particular temperature. The third condition you need to complete is the temperature. If these things are written, then you are writing the correct definition. This is answer for the A part. Once you come to the B part, in the B part, you are asked, if you take these combinations, what factor that affects solubility that can be shown by each of the following pairs of test tubes? First combination is A and B. If you take A and B, between A and B, the only factor that differs is temperature. Both are magnesium chloride, both are distilled water. One is at 25 degrees Celsius, other one is at 60 degrees Celsius. Mean the factor that varies between A and B is temperature. So for B, Roman number 1, for B, Roman number 1, you need to say temperature as the answer. Second combination, they are asking between C and D. If you take C and D, both the temperatures are same, both the solutes are same. This is distilled water, this is kerosene, mean only solvent is different. Other factors are same. So second one, you need to write nature of the solvent. Nature of solvent. Second question's answer. Once you go for the third one, D and E, they are asking you to compare. Both the ones are 25 degrees Celsius, both the ones are kerosene. One is sugar, the solute, other one is grease, the solute. So third factor that should be written here is nature of solute. So these are the answers for question number B. Okay, so I'm making it a little closer to you to see the past paper clearly. And now coming to the question number 3. In the above experiment, 1.9 gram magnesium chloride was added to the test tube A, and the total volume of the solution formed was 10 cubic centimeter. Find the number of moles of magnesium chloride. First thing, you have to find the molar mass of magnesium chloride. For finding molar mass of magnesium chloride, you will be getting separate marks. So here magnesium and 2 chlorine are there. Okay, so magnesium is 24, 1 chlorine is 35.5, so 2 chlorine 71. So once you add them, you will get 98. Now finding 98, some children just write 98. No marks for you. GMOL minus 1. If this unit is written only, you will get marks. Keep in the mind. Right, now for a question, yet we have not answered. You have to write this formula. Mole equals to mass divided by molar mass. Okay, that one you have to write. And thereafter, okay, you have to substitute 1.9 gram divided by 98. 98 GMOL minus 1. Now this one we need to get the answer. Actually is going to be a decimal answer for you. Okay, so you are OL children, you are not small ones. Okay, sorry, it's a small mistake. This is 95. 95. So this is also going to be 95, right? So 1.9 divided by 95. Once you divide it, 1.9 division 95, giving me 0.02. So my answer is going to be 0.02 mole. Okay, so this is the question number A's answer. Question number B, when you consider, calculate the concentration of magnesium chloride. Now I notice children are just dividing and getting the concentration. No. In concentration, you know, this is the formula for concentration. Concentration equals to, okay, mole divided by volume. This is the formula. In the formula, my children, you have to understand volume should be applied in cubic decimeter. Here they have written the volume in cubic centimeter. So 10 cubic centimeter equal to 10 over 1000 cubic decimeter. That means 1 over 100. That means 0.01 cubic decimeter. When I went through some of your works, I noticed that child has applied volume in cubic centimeter. By applying cubic centimeter, she gets the answer. Okay, her answer is correct, but she will not get any marks. Keep in the mind. Okay, and thereafter we come to the concentration formula. Concentration equals to mole divided by volume. mole you have already found, 0.02 mole. Concentration, volume you have now found, 0.01 decimeter cube or cubic decimeter. Once you divide them, you will get a clean answer, 2 mole per cubic decimeter. 2 moles per cubic decimeter will be your answer. So this is the B part answer. Now the last question, with that one this discussion is finishing. Water is a good solvent. Write 2 special properties possessed by water due to intermolecular forces. There are few properties mentioned to you. Water has a high boiling point due to intermolecular forces. Due to intermolecular forces, water has a high boiling point. Similarly, water has a high specific heat capacity. It is also due to the intermolecular forces in it. Thirdly, okay, water is a liquid in room temperature. That is also due to the intermolecular forces in it. So hope this discussion would be useful for you. I'm sending the next question to you today. You children do it and send me the answers as usual. Good luck.